A quick example problem to show the derivation of the NRCS triangular unit hydrograph. We have a watershed whose curve number is 86. In fact, it's the same watershed from the previous example problem. Its area is going to be 3 square miles. The average slope in percent is 3%. The longest length, the length parameter from farthest extent of the watershed to where we're deriving the unit hydrograph for is 1.2 miles, or 6,336 feet. All right, so we're going to look at the equations we just went through in the lecture and calculate our T sub L. It's L to the 0.8 times S plus 1 to the 0.7 divided by 1900 S percent to the 0.5. We know L was given to us. We know S percent, but we need to calculate S, which remember is 1,000 divided by the curve number minus 10, which is 1,000 divided by 86 minus 10, or 1.63. So we can rewrite T sub L 6,336 feet. L is in feet. I think I might have forgotten to mention that in the lecture. To the 0.8 times S, which is 1.63 plus 1 to the 0.7, divided by 1900 times 3 to the 0.5. And when we do that, we get a T sub L of 0.66 hours. T sub L gets calculated in hours. We can calculate T sub C from that because T sub C happens to be 5/3 T sub L. You can derive that by what's shown in the lecture material, and that winds up being 1.1 hour. I could have also just directly calculated T sub C using the formula from the lecture, which is exactly the same formula as T sub L, except instead of 1900 in the denominator, it's 1140. Now I have T sub C, so T sub P is equal to 0.67 T sub C, which is 0.74 hours. And then we've got the time to base, T sub B, which is 2.67 times T sub P. So it's 1.97 hours. And then finally, Q sub P is 484 times the area, 3 miles, divided by T sub P, which is 0.74. And that's equal to 1962 CFS. So now I have everything I need. I can draw this out where I'm going to go over my T sub P, which is 0.74 hours, and up my Q sub P 1962 CFS. Got a point there, connect here. And then my time to base, which was 1.97 hours. It's going to be over here. I'm going to connect from here to here. And that's my triangular unit hydrograph using the NRCS methods. If I wanted to turn this into curvilinear, now that I have it, I can look up table 8.8.1 in my book and derive the flow value for each time interval based on this peak, and then draw the curvilinear.